Today we're going to continue looking at volume, but we are going to be working backwards with our problems, which means that I'm going to be giving you the volume of a shape, and your goal is to find a piece that would have created that volume. So just a quick reminder of the 5 different formulas that we've looked at in terms of volume. We've looked at volume of prisms, volumes of pyramids, cylinders, cones, and spheres. So I would highly suggest that you pause the video and write these things down and label which volume it is. So prisms is this volume and pyramids is this, because you're going to want to know the formula for each of them in order to help you out with today's lesson. So today, like I said, we're going to be working backwards. So notice this first example says, we want to find the height of a rectangular prism given the volume is 288 inches cubed and the area of the base is 36 inches squared. So notice that in this particular problem, like I said, I'm giving you the volume. It says volume is 188 inches cubed. All right. So, well, if I know what the volume is, I know that I'm going to be substituting that number in for the variable of V. So V is going to then turn into 288. Now, we have to know what the shape is that we're talking about. In this case, we are talking about a rectangular prism. Regardless of what shape the base is, the moment I see a prism, thinking about the formulas, we know that volume of a prism is the area of the base times the height of the prism. Notice that the other piece of information that I have given us is this last part of the sentence right here, where it says that the area of the base is 36 inches squared. So that means that I get to plug that number 36 in for that B, which stands for area of the base. And like the problem asks, it wants the height. Well, so then that's why I don't know what H is. Our goal is now to solve for H. So hopefully by substituting the numbers into the correct variables, it makes sense that in this problem, all I have to do to solve for H is divide. I'm going to divide both sides by 36. That gets you H by itself. And 288 divided by 36 is going to give you 8. Now, I do want us to also be aware of our units. Once again, when I gave you your volume, notice how the inches were cubed. When I gave you the area of the base, well, area, we're talking inches squared. What I'm asking for is just the height. Height is just a singular unit. So since our unit's inches, this height turns out to be 8 inches. And that's our answer. In the next one, it says the volume of a pyramid is 294 inches cubed. If its base has an area of 63 inches squared, we want to find the pyramid's height. All right, so volume equals, notice this time we're talking about a pyramid. So if we think about the formulas, we know that to find to find the volume of a pyramid, we're doing 1/3 times the area of the base times the height. So now I want to start plugging in numbers. 294 is representing volume. Volume is V. So 294 is going to equal. We'll still have the 1/3, but now notice that this 63 is the area of the base, and area of the base represents that capital B. The question is asking for us to find the height, and that's what H stands for. So now we can go ahead and start solving. The nice thing about the right-hand side is 1/3 of 63 is something that is actually divisible. Okay, if I take 63 and divide it by 3, we will get a nice number. 63 divided by 3 is going to give us 21. And now we're back to what we did on the last slide. If my goal is to solve for H, this is now a one-step equation. I'm going to divide both sides, in this case by 21, and that gives us a height to be 14. Thinking about our units again, volume, we want our units to be cubed. Area, I want my units to be squared. When I'm talking about height, I just want units. So it'd be 14 inches as the height. This next example is asking for us to find the radius of a cylinder if the height is 18 feet and its volume is 162 pi feet cubed. All right, so we're talking about a cylinder. I'm going to write the formula for a cylinder first. The formula for volume of a cylinder, remember, is pi times the radius squared times the height. Well, in this problem, notice that 18 is representing the height. So I get to plug 18 in for H. 162 pi, and don't forget pi is a part of that number, that's representing volume. So 162 pi is going to go in for V. And now our goal is to solve for R because I'm asking for us to find the radius. So in order to get R by itself, there are two things that are being multiplied by R. There's a pi and there's an 18. Well, the opposite of multiplication is division. So I'm going to divide both sides by 18 pi. The nice part about that is that the pi's cancel, and now we are just dividing two numbers, and we don't have to worry about pi anymore. So now that gives us 9, and that equals our radius squared. So we're still not done because R squared is not the radius. So how do we get rid of a square? We take the square root. So that gets me my radius by itself. Because we're talking about a length to get us our radius, I can't have both a positive and negative. So I just want the positive. Square root of 9 is 3. And just like all our other examples, if we're thinking about our units, we want this just to be feet because we're not finding area, we're not finding volume, so we want our units to be singular. So 3 feet would be the length of that radius. The last example, we're going to find, given the volume of a sphere to be 972 pi inches cubed, we're going to find the radius of the sphere. So we're talking about a sphere, and so I know that based off of the formula, it's 4/3 times pi times the radius cubed. Notice that the only number that's given is the volume. So I'm going to be plugging that in for V. And once again, don't lose the pi. Pi is a part of that number. So now my goal is to start solving for R. So the first thing I'm going to do is I'm going to divide by pi. Because notice that when I divide by pi, it cancels it out on either side. So now I just have 972 equals 4/3 times my radius cubed. So because there is a fraction in front, you can divide by that fraction because the fraction is being multiplied by the radius cubed. However, I always have talked about instead, let's multiply by the reciprocal. And so if I multiply by the reciprocal, which is 3/4, I have to do it to both sides. Think about that. 972 is over 1. You can multiply those numbers straight across. So 3 times 972, that gives us 2,916. 4 times 1 is 4. That equals R cubed. Now I can divide that. When I divide that, I get 729 to equal R to the 3rd power. To get the radius by itself, it's similar to what we did in the last example, except because we are cubing the radius, to undo a cube, we're taking a cubed root. So to take the cubed root of both sides, similar to what we did when we took the square root, we are looking in this case, because our little number here, our index is 3, I'm looking for 3 of the exact same number that multiply to get us 729. All right, so if I was to just do my guess and check, hopefully we come to the realization that it's 9 times 9 times 9. It's the same number 3 times that multiply to get us the 729. Now, if you have a calculator, there are buttons that will allow you to do this. If you use the Desmos calculator that I have in the Schoology page, then you'll see a button on your calculator that looks like this. You would type that button, and then you would just have to arrow over and make sure that you type a 3 in the spot of where that n technically is. If you are using your own scientific calculator, you might see something that looks like this in your calculator, kind of close to the square root. What you would have to do when you're typing that in is that in this case, you'd have to actually type 3, then you would hit that button, and then you would type in the 729. Okay. A third way that you can think of this is you can actually think of it as 729. If you hit the caret button to get an exponent, then you can do 1/3 as the exponent, and that will also get it to be what you want. We turn out then to get our radius to be 9. And if I look at my units, I only want the length singular. Okay, we're not finding area, we're not finding volume. So that would just be inches, so 9 inches.